Hey, Jessica. All right, let me share the screen. So I'm gonna pull your quiz up. Oh, just pretend like you don't see that. Here we go. All right. So on the ones that you missed, let's take a look. Um, when you are doing this one, you have to know your logarithm rules. And so one of the properties of logs is if you have the same base here as the number here, kind of cancels out and it gives you a 1. Okay. So this one has the same number here and here. So those kind of cancel out and it gives you a 1. This one you would put in the calculator as log of like 1 over log of 13. So this is the common log formula, or you can just plug it in the calculator. So if you put in the calculator log of 1 divided by log of 13, and that one's going to give you 0. And the same thing, notice how here the base is the same as the number beside it. So that's going to give you a 1. And then the last one would be log of 1 over log of A. Okay, so this is called the change of base formula, where you always take the number here of log and divide it by the log with the base. But actually, there is a property that if you have a 1 here, it's always going to be equal to 0 anyway. But so that's the other property. Okay. Let's go to another question. Oh, here we go. All right, question 5. Let's take a look at this one. So we want to solve this one. And so we have a log of 5 on the side and a log 5. So that means they have the same base, which is good. That means we can solve it. So when you have a log with the same base on each side, you can cancel these out. But before you do that, you have to be able to move this so it's in the back here and move the 3 so it's in the back of here. So you would have log base 5 of x to the second. Again, this is a property of logs. And this will be a log base 5 of 4 to the third. So the number in the front of the log becomes to the back of it. That's one of your properties. And then what happens is you can just cancel these out. And you're left with x squared equals 64. And then we square root, and so you get x equals a plus or minus 8. Now the problem is if you take this and plug it back in to the original equation, -8 would go here. And we remember the properties of logs. One of the properties is that your domain has to be greater than 0. Okay. So -8 would not work. So therefore 8 is the only answer on that one. All right. We get we got all these. Oh, wait, let's do this one question. So then this one, the same thing. You have the log of 4 here and a log of 4 here, so we can cancel those out, and you're left with x plus 2 equals 8. And you subtract 2, and you end up with x equals 6. And you check it, it'll still work. Okay. So down to some more questions. That one. That one. Got that one. Let's do this one. So again, you want to solve for x, so we need to get this by itself. So we can divide by 8, So we have 3 to the power x equals 5 over 8. Now, exponential equations, remember, one of the rules, one way you could do it is if you can get the same base. Well, there's no way to get 3 and 5/8 as the same base. So then the other way to solve this would be to write it as an exponential. And so the way to do that would be log Your base of your exponent becomes the base of the log. The number on this side becomes beside it is equal to x. And now this one is one that you could just plug in the calculator with the change of base formula. And so you would do log of 5/8 divided by log of 3, or some of the new calculators, you can actually just enter that in. And when you do that, you would end up getting this, okay? And you can have a negative for the exponential, just not the logarithm. Got that one. All right, this one, got all these except for this one, right? So again, how do you solve an exponential? One way to do it would be either rewrite as a log, or you can have it so that it has the same base. And so think of a number, think of 2 here. Okay, you want to have a base of 2 here. So what exponent would have to go here that would give you 16? It would have to be 4, right? So x is equal to positive 4 would be that one, not negative. Okay. All right. This one, an exponential equation. So when I look at this, it may be helpful to see, okay, if I rewrote this like this, or let's see, this. Notice that this is technically a quadratic, okay? And so what you can do is you can use U substitution and rewrite this so it's just an easy quadratic like this. See that? So what I did is I saw, okay, this can be written as 2 squared, and then I can rewrite both of these so that I have the same number here, and that's being squared, so I know it's quadratic. So now let's solve this like a basic quadratic, and then we'll plug this 2 to the power x back in there. So what are 2 numbers that multiply to give me -12, but add to give me -1? Because that's my middle number, right? I'm factoring here. And I know it's going to be a 3 and a 4. And it's going to have to be a -4 because that's a -1. So this becomes u minus 4 times u plus 3 equals 0. We set both of these equal to 0 to solve it. So u equals 4, u equals -3. And then the last thing I would do is substitute that back in. So 2 to the power x equals 4, and 2 to the power x equals -3. And now how do I solve this? This will be 2 to the x equals 2 squared, right? And those cancel, so you get x equals 2. And then this one would be hard to do. This would be, you would plug this in like that because it can't have the same base. And so you would get log of -3, enter, and you can't do log of -3. So that one you wouldn't use, and the only answer would be log of 2 because you can't have log as a negative number right here. Okay. That was a little bit more difficult question. Okay. Let's see what else we got here. All right, the only one you missed here was this one. Let's see. Remember that this is technically when you have an ln of e, the base here is understood as the e, right? So again, these would cancel and you would be left with x equals 5. Okay. Another way to write it, you could do e to the 5th equals e to the x like that, because this is understood as a e. So you could change it to exponential, and then those would cancel and you would be left with that. So another way to do that. Question 12. Same thing, those, we already did that one. All right, here is one. Let's do this one. So again, in order to solve this, you would have to have, there's no log on this side. So the only way to solve this would be to put it as an exponential function. And to do that, we would have to rewrite this so it's one single log. And there was some directions on that in the book and notes. So to do that, we have the same base here, which is good. And we have a minus. So that means we can rewrite this as a division like this. Okay. And then what we would do is we would rewrite this as an exponential. So this will be 4 to the power 3 equals, and this is technically x plus 3 times x minus 3 over x plus 3, right? And so that really cancels. And so you're left with 64 equals x minus 3, and then you add the 3, which gives you 67. Okay. It's that one. All right, that was it. Okay, so I hope that cleared some questions up for you. Let me do a few with you on, let's do on interval notation. I'm just going to kind of make things up. So when you think about interval notation, you can use an interval notation for like domain and range. You could use it as writing your answer for inequalities. So let's just do a basic one. Let's say we have something like this. X plus 3 is less than 4. To solve this, we would subtract 3. X is less than 1, right? So if I'm going to write this in interval notation, you think about a number line. We have 1, 2, 0, -1. When you look at this, okay, less than or greater than is always going to be an open circle, and less than or equal to, greater than equal to are always going to be a closed circle. Okay, so we would have it open on the 1, and then we want numbers that are less than 1, so we would shade it to the left. Okay, now to write this in interval notation, we're going to keep on going to the left. So that means negative infinity, and we read from left to right. So this will be from negative infinity to 1. And we will leave it open here because this is an open circle, and we would have to leave this open because infinity or negative infinity goes on forever and ever. So that's how we would write that in interval notation. So as far as looking at a graph, right? Let's say I want to say the domain and the range of this graph. And I want it in interval notation, okay? Let's say this is at 0, 3, okay? If I'm looking at the domain, this arrow means it's going to keep going towards the left, and this arrow means it's going to keep going towards the right. So if you're going to the left forever and ever and ever, that would be negative infinity. And if you're going to the right forever and ever, that would be positive infinity. Okay, so this is an interval notation. You would have parentheses around those. Okay. For the range is going from the bottom to the top. So look down here. There's nothing down here, nothing. The graph starts right here on 0, 3. And range is the y value. So we start at 3. We are including 3. So that would be a bracket. And then we're going up. And there's an arrow here. So that means we would go to positive infinity, and it would be open there. That makes sense. Okay. So we would write that as 3 to positive infinity. Okay, here's another one. Say we have let's say we have this circle and we want to do the domain and the range, okay? The domain is what's being covered on the X, and the range is what's being covered on the Y. So from here to here is being covered. This starts at -2 and stops at 2. So we will go from -2 to 2, and we are including both of these, so we would have brackets on those. And then the range here again starts at -2 and goes up to +2. So again, we go -2 to +2, and these would be closed on those. Okay. We could do one like this that starts here and goes up like that. So if you were stating the domain here, it starts on the X at +2. We're including it. And it goes on forever. Okay, and the range, excuse me, starts at +1. So we're going up to the y, right? Starts at +1, and we're including that, and it goes to positive infinity. Okay. Excuse me. So I hope this helps a little bit. I'll see if I can find a few more videos on this for you and send that as well. But let me know if you have any more questions, and I will be happy to answer any more questions. Okay. Thanks. Here is my stop share.